So now let's go with our question number 7. Here we have our question. A box contains 16 cards where the number of on the cards are from 1 to 16 respectively. And a card is drawn at random from the box. Out of 16, one card is drawn at random. And here we need to find the probability of that card in different cases. Whereas the first one is we need to find the probability of getting an odd numbered code. Odd number. How many odd numbers we will be having? First, we need to write the sample space. What will be our sample space? All the numbers from 1 to 16. 1 to 16. These are the elements in our sample space. And what are the elements in this favorable outcomes? We'll be having all the odd numbers, which is equals to 1, 3, 5, 7, 9, 11, 13 and 15. Up to 15. These are our favorable outcomes. This is n of e. Number of events is equals to 8. And we know our n of s is equals to 16, which is the number of elements in sample space. And the probability of getting this event 1, that is the probability of getting an odd number, is n of e by n of s, which is equals to 8 by 16. Whereas this 8 by 16 can be simplified as 1 by 2. Next, we have the question to find the probability of getting a prime number. Here we need to find the prime numbers between 1 and 16. So here the prime numbers are 2, 3, 5, 7, 11 and 13. So these are the favorable outcomes for this second condition. Our n of elements. How many elements we have here? 6. And whereas our n of s remains the same, which is 16. Now we have the probability of getting a second event, which is equals to 6 by 16, which can be simplified as 2 3s are and 2 8s are, which is equals to 3 by 8. This is our second probability of getting a prime number. Next, we need to find a probability of getting a number divisible by 2. So divisible by 3. Divisible by 3 is nothing but the multiples of 3, which are 3, 6, 9, 12 and 15 we'll be having. So our n of e is equals to how many elements we have? 5. And our n of s remains same, which is 16. And the probability of getting the third event is equals to 5 by 16. So thus we cannot simplify this. And we have our fourth one, where we need to find numbers which are not divisible by 4. Not divisible by 4 means non-multiples of 4. That means here we'll be having 1, 2, 3. 4 will not take, which is because it is a multiple of 4. 5, 6, 7, 9, 10, 11, 13, 14 and 15. So how many elements we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Our n of e is equals to 12 and our n of s is same, which is 16, and the probability of this fourth event is 12 by 16, which can be simplified as 3 by 4. This is our question number 7. So here we have our question number 8. There we have cards bearing numbers from 2, 4, 6, 8, 10 up to 20. Here we just have only even numbers which are kept in a bag, and a card is drawn at random from the bag. We need to find the probability. Same. First we'll write the sample space, which is 2, 4, 6, 8, 10, 12, 14, 16, 18 and the last one is 20. Number of elements in sample spaces 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So there we have 10 elements in sample space. First we need to find the probability of getting a prime number. So as we know, except 2, all the numbers are composite numbers. So here we'll be having only one element here. N of e, the number of favorable outcomes are 1 and the total outcomes are 10. The probability of getting this first event is 1 by 10. Whereas our second one is to get the number which are divisible by 4. Divisible by 4 means the multiples of 4. What are the multiples of 4 from this? 4, 8, 12, 16 and 20. These are the multiples of 4. How many elements we have in favorable set? We just have 5. And the probability of getting the second event is 5 by n of s, which is equals to 10. This can be simplified as 1 by 2. And whereas a third one is to find a number which is multiple of 6. Multiples of 6. So direct question, multiples of 6 are 6, 12 and 18. So how many favorable outcomes we have? 3. And total outcomes that we know, which is equals to 10. The probability of getting this third event is n of e by n of s, which is 3 by 10. This is the probability of getting multiples of 6 out of 1. And next we need to find the probability of getting an odd number. As I said before, all the numbers are even numbers here. So here favorable outcomes will be equals to 0. We don't have any elements here. Favorable outcomes, n of e is equals to 0. And our n of s is equals to 10. And we know 0 divided by anything. The probability of getting this fourth event is 0. We don't have any odd numbers here. So here we have our question number 9, where a box contains 15 balls bearing numbers from 1 to 15. Each ball is having one single number respectively. A ball is drawn at random from the box. We need to find the probability. So first, as usual, first we need to write the sample space, which is from 1 to 15. All the numbers from 1 to 15. So what are our total outcomes? 15 we have. Total outcomes are 15. So first we need to find the probability of getting an even number. Probability of getting an even number. What are our favorable outcomes? 2, 4, 6, 8, 10, 12 and 14. So up to 15, right? So we'll write only up to 14. So favorable outcomes. How many favorable outcomes we have? 1, 2, 3, 4, 5, 6 and 7. And our n of s is equals to 15. The probability of getting this first event is 7 by 15. That is n of e by n of s, which is equals to 7 by 15. Second one is the probability of getting a number which is divisible by 5. Divisible by 5 means the multiples of 5. Multiples of 5 are 5, 10 and 15. Our favorable outcomes. How many favorable outcomes we have? 1, 2 and 3. And total outcomes are 50. The probability of getting the second event is 3 by 15, which can be simplified as 1 by 5. This is our second one. Next we need to find probability of getting a number 6. Probability of getting a number 6. So as we know, we'll be having only one single digit from 1 to 16. So favorable outcomes are only 1. And the probability of getting this third event is 1 by 15. And next we have our fourth one, which is to get a probability of numbers which are lying between 8 and 12. So what are the numbers we'll be having? 9, 10 and 11. So how many favorable outcomes? Favorable outcomes are 3 and total outcomes are 15. The probability of getting this fourth event is again 3 by 15, which can be simplified as 1 by 5. Next we have to find the probability of getting a number which is greater than 9. So all the numbers which are greater than 9 are 10, 11, 12, 13, 14 and 15. Favorable outcomes are 1, 2, 3, 4, 5 and 6. And n of s, which is equals to 15, and the probability of getting this fifth event is 6 by 15, which can be simplified as 3 2s are and 3 5s are, which can be simplified or written as 2 by 5. Next, we have our sixth question. Here we need to find the probability of getting a number which is less than 6. We need to find the probability of getting a number which is less than 6. So all the numbers up to 5. So favorable outcomes are 5 and total outcomes are 50. The probability of getting the sixth event is 5 by 15, which is equals to 1 by 3. This is our question number 9. So here we have our question number 10. There are 25 discs which are numbered from 1 to 25 which are kept in a closed box and shaken thoroughly. A disc is drawn at random from the box. We need to find the probability that the number on the disc. So here we'll be having different cases. First, the sample space will be having numbers from 1 to 25. That is, our total outcomes are 25. So first we need to find the probability of getting an odd number. So we need to find the odd numbers from 1 to 25 which are 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, 21, 23 and 25. So we need to find the count n of e, number of favorable outcomes, which are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and 13. And our total outcomes are 25. So the probability of getting this first event is 13 by 25. And we have our second one, which is to find the numbers which are divisible by 2 and 3 both. So it should be divisible by 3 as well as 2 both. That means simply we can just find the multiples of 6 which are 6, 12, 18 and 24. These are the numbers which are in between 1 to 25. Number of elements in favorable set are 4 and our total elements are 25. The probability of getting the second event is equals to 4 by 25. And next we have our third one, which is to find a number less than 60. So the number less than 16 means all the numbers up to 15, from 1 to 15. Number of favorable elements will be 1 to 15, that means 15, and total elements as we know, which is equals to 25. The probability of getting this third event is 15 by 25, which can be simplified as 3 by 5. Next we have our question number 11, which is in a class of 40 students. So total we have 40 students. From this, out of 40 we have 16 boys and the rest are girls. We need to find, and from this 40, one student is selected random. We need to find the probability that the selected student is girl. First we'll write the given values. Number of students. How many students we have total? We have 40. Number of boys is equals to that they have given, which is equals to 16. So to get the number of girls, we need to subtract the number of boys from total, that is 40 minus 16, which is equals to 24. There we have 24 girls out of 40. And the probability of getting girl is, what are the favorable outcomes here? Favorable outcomes are n of e is equals to 24, that we know because we have 24 girls out of 40, and total outcomes we know, that is total students, which is equals to 40. And the probability of girls is equals to n of e by n of s, which is equals to 24 by 40. This can be simplified as we know, 8 3s are 24 and 8 5s are 40. So the probability of getting a girl is 3 by 5. So question number 12, a bag contains 8 red, 4 white and 3 black balls, and 1 ball is random at random. We need to find the probability, and here we will be having different cases. Before going to that, first we need to find the number of balls. Number of balls, that is 8 red plus 4 white plus 3 black balls is equals to, total we have 15 balls. So, and from this 15, one ball is chosen at random, and out of this, first one is to get the probability of getting a white ball. So white ball. How many favorable outcomes we have? There we have 4 white balls. That is, our n of a is equals to 4, and as we know, our total outcomes are 15. The probability of getting this first event is n of e by n of s, which is equals to 4 by 15. And next we need to find the probability of getting red or white ball. Red or white. It may be red or white. So red and 8 means favorable outcomes will be equals to 8 red plus 4 white, which is equals to 12. And our n of s is 15. The probability of getting the second event is 12 by 15, which can be simplified as 4 by 5. And next we have a third one, which is the probability of getting neither red nor white. So we should not get red or white. So remaining only black should get. So black should get means n of a is equals to 3 black balls we have. And our n of s is equals to 15. The probability of getting this third event is 3 by 15, which can be written as 1 by 5. Next we have the probability of not a red ball. Not red ball. Not red ball means it may be white or black. White or black. That is, favorable outcomes are 4 white balls plus 3 black balls, which is equals to 7. And the probability of getting this fourth event is n of e by n of s, which is equals to 50. This is our question number 12. Next we have a question number 13, which is bag contains 6 black, 5 white and 9 green balls. And as usual, one ball is drawn at random. We need to find the probability of getting the balls in different cases. Before getting into that, we need to find total balls. Total balls is equals to 6 black plus 5 white plus 9 green. So total we have 20 balls. After that, first we need to find the probability of getting a black ball. Black ball. How many black balls we have? N of e. There we have 6 black balls, and our n of s, which is equals to total balls 20. And the probability of getting this first event is 6 by 20, which can be simplified as 3 by 10. Next, the probability of getting not a green ball. Not a green ball. Not green. Not green means we may get black or white. So our n of e will be equals to 6 plus 5, which is equals to 11. And the probability of getting the second event is n of e by n of s, which is 11 by 20. Next, question number 3. Probability of getting either white or green. White or green. So n of e is equals to both white and green, that is 5 plus 9, which is equals to 14. And the probability of getting this third event is 14 by 20, which can be simplified as 7 by 10. Next we have our fourth one, which is the probability of getting neither. Either is different, neither white nor green. So we should not get white as well as green. So we have an option of getting black. So our n of e is equals to 6. And we know our n of s is equals to 20. And the probability of getting this fourth event is 6 by 20 again, which can be simplified as 3 by 10.